Well, welcome to week 9. We're almost done. So we'll have a full 3 classes, Thursday of this week and both classes next week to work on review stuff. Which basically just means that people didn't ask enough questions so far this term, and instead of 1 review day at the end, we get 3, but that's okay. Now you'll get all of your questions now. And since it's good for me to be a responsible teacher, we have a readiness check here at the end. All of these things to help us see if we're ready for Math C and no questions to ask. But today, we're not going to worry about finishing. We're just going to talk about circles. So, okay, the whiteboard is working for you. See if you can do this puzzle. I would recommend using the highlighter colors, not the pen colors. They just are a little more forgiving coloring. So if you use the pen, don't use the top one, but the second one. And then how many colors are needed to make it so no 2 jigsaw puzzle pieces are touching. So we can make more different. I'm not sure if you inherit the colors I pick or not. You have to make your own color pick. And I'm gonna bring everyone towards me so that I have to find this one. And I think I'm gonna erase my yellow in case no one likes yellow. Then you can use whichever colors you want. Nope, no, don't double color things, Judy. He picked that one as red, so.
No, I have no idea what that one. Gavin took it from me.
Well, he's quicker, so he gets that one. You get a different one. You would think after 9 weeks you would cooperate better.
No one wants to cooperate. There's no teamwork that is wanted. The best one that cooperates like a team is Bertha, honestly.
Well, Betty is a good cooperator.
Yeah, tell me again. Sorry, I just
That's okay.
running.
I was just complimenting you on your teamwork.
This task, how many colors does it take to color the jigsaw puzzle so that no adjacent pieces are the same color? You don't want the same color touching.
Yeah, okay.
So we could do, whoops. So if we made this one yellow and that one yellow, we can kind of do every other piece yellow.
So we have to use different color?
Right, we want to have no pieces the same color touch.
Okay.
So I can't do this one yellow because then it would be touching another one that's yellow.
Okay.
Can we do it with only 3 colors? Do we need 4 colors? You even need 5 colors.
Okay.
Okay, I'm going to look up at this area. We have red and yellow, and they have to be different because there's 2 things touching. Both of them touch this one. So this has to be a third color and someone picked green. I'm a little worried that on some computers, the yellow and the green will look too similar. So.
I can tell the shades apart.
That's what happened, yes.
So I'm gonna make green a little different there. Let's see, this can be green. And this can be green, you can put in green in the middle. Between the yellows. Can I put any greens on the middle part of the circle?
Yeah,
If I put a green here, that doesn't work because it touches two other greens.
yeah,
Can I put a green here? No. Here, no. Here, no. So we need a fourth color. Yellow, green, and red aren't enough.
Well, there's blue. I chose that in the middle.
Oh, okay.
At
So
least for one.
Why
There's
don't you go
one
ahead and
blue.
make those blue? In between the reds, and then we can talk about the middle of the circle, but don't do the middle yet, put the blue
Oh.
in between the reds on the center ring. Okay, now I'm gonna look at this piece. Can it be red?
It can be yellow.
It could be yellow, it can't be red because it touches that, it can't be blue because it touches that, but it could be yellow.
Mm-hmm.
Can anything else in the middle of the circle be yellow?
A green.
I think this one might. Does it count as touching if they're just touching on a corner like that? It's a little bit vague.
I think it does, but you're a boss.
Then we can do green. We can have one be green.
Mm.
So it looks like now we're down to this definition. If this one counts as touching the yellow above, then we need another color. Because it can't be yellow or green or red or blue. If it doesn't count as touching, we could make it yellow again. And similarly with this last piece, if this doesn't count as touching green, because that little corner doesn't count, then we can make it green. But if that would count, then we need some other color we still haven't used yet.
So does it count as
I
touching or
don't know.
does it not?
I didn't make up this puzzle. So,
Well, we're gonna need some sort of guidance. Could you just decide?
no, because no one's grading us, there might not be one is. So if touching at only a corner does not count as touching. Then how many colors work? Yellow, green, red, blue, then
or,
4 colors is enough. But if touching at a corner does count, then in the middle, middle. Come on, M. Yeah. We need 2 more colors, so 6 colors total. Did I say that okay?
Yeah.
Okay, so that was our warm up for today, mostly because it looks like a circle. So now we're going to talk about circles. We have already talked about perimeter. With perimeter, you add up the edges. And again, the warning that I keep mentioning with perimeter is it's nice to mark a corner and which way you're going, Cause adding up 5 plus 4 plus 6 plus 8 plus 9 is really easy, especially with a calculator to do it for you. The danger is just if you double count a side, or if you forget a side. So that mark helps you not make a careless mistake. We also talked about area. How is the area of this rectangle, I'm not rectangle, triangle, half of the rectangle around it? And you could see that it was, if you grab one of these, whoops, one of these corners and move it to the other side, then you can see, yeah, it's half of that shape. But
Looks kind of like a bird's eye view of a tilted pyramid.
yeah. For circles, though, that doesn't work. We have to find a different way to make an area formula than with all the other polygons. Because drawing a rectangle around the circle doesn't really help us in the same way. We can't say it's a half or it's the same like we were doing before. So now I'm gonna need a volunteer. Can I use you?
Yeah.
Oh, this is, okay, so I'm going to pretend that this goes straight through his skull from ear to ear, right? As wide as his head is. So my question is, how many head widths does it take to go around? So 1, 2, and not quite 3. Okay, now let's try your arm, so hold the arm out straight. Imagine that we can somehow shove this right through his arm and get how wide his arm is. Right. A part of the reason that wasn't quite right is 1, 2, that one's a little more than 3. Everyone with me for what we're asking?
Mhm.
Oh, so. The answer is going to be different from person to person, because our heads and our arms aren't actually circles.
Mhm.
But there's something where you can kind of see a pattern where the height or the width of a circle, because again, for circles, it doesn't really matter if you say height or width, it's just turning it, right? So the width of the circle is about a third of the distance around it. Something like that. Okay. There is a animation here that does that. It shows you that this is one width of the circle. It starts by saying, look, the circle fits between 0 and 1. So they're measuring widths of the circle, not inches or anything.
Mhm.
And how many circle widths does it take to unwind a red string that goes around the wheel? It's a little bit more than 3. So the ancient Greeks made a name for the answer to this question, and they called it pi, and that's why we have the Greek letter pi there. And all it means is that when you unwind the string from around the circle, the length is a little bit more than 3 of the circle's width or height or whatever. So don't think of it so much as a formula, it's mostly a definition. We will write something like the circumference, which is the fancy word for perimeter of a circle. I'm not sure why we need a second word. But tradition, circumference. And then people will say that that's pi. Pi times diameter. And they'll use a D for diameter, and diameter again is circle width. I usually say width instead of height. Again, it's the same for circles.
What the heck?
It doesn't matter whether I'm looking at how tall it is or how wide it is, it's the same. But on tests like the GED, since it's a GED class, they tend to draw things sideways for their diameters rather than up and down. So if I start saying width, and I kind of get too used to how the GED. So this is a formula. If you plug in a length like 3 inches for the diameter, you can take your calculator and say 3 times pi and see how long a string would go around that circle. But besides the formula, it's basically just kind of how circles work. It takes a little more than 3 strings, pi strings, to go around. If you ever forget what pi is, you can always do pi times 1 on your calculator and it tells you pi. You don't
Is
have
this
to.
pie that we eat?
No,
I was being funny, I knew that.
okay, so now I have a kind of magic thing. And if we had more math, I could explain why this works. But for now, you just have to trust me.
Okay.
So I'm going to ask you a different question. If I have a circle and I'm now talking about the radius, and the radius is half of the diameter, going from the middle out instead of all the way across. And you'll see why I'm switching on you in a moment. Okay, so I'm gonna erase that one. Okay, so if I have a circle and I know how long it is from the middle to the edge, then I'm wondering how much area it would take. I'm gonna start the way we did with our other polygons with folding rectangles of paper. Let's surround it in a rectangle, which in this case is a square, because circles are symmetrical. And I want to show you that the reason I picked R is that this length is R, because it's the same as that. And similarly, whoops, this is going from the middle to an edge, so this length is also R. So both of these edges of the box are R, and that means the area of the whole box is R times R, length times width. So the whole box around the circle is 4 R times R's. Each of these little brown boxes is an R times R, so the whole thing is 4 R times R's. Now, the circle doesn't cover all 4. Right? There's these yellow bits that kind of stick out in the corners. So the circle is smaller than that. How many R times R's does the circle cover? It looks like it covers more than half. Right? The brown part is more than the yellow part. It looks like it might even be more than 3 of them. Is the circle more than 3/4 filling that square? So the part you just have to trust me on, I warned you we would get to that, is when you say, how much of that box does the circle itself cover? The answer is, again, more than 3 and less than 4. And it's the same more than 3 and less than 4 as we dealt with for the diameter. It's this pi times R times R. So I'll take my spoiler here. Make it big. So when we write as a formula, that area of a circle is pi times R, whoops, I should make an X, times R times R. Now the R is radius, So halfway across. Then that's what this formula is saying. That it covers more than 3 of those brown boxes, but not all 4 of them. And it's a formula, you can plug things in. We could say, what is the area if the radius was 5? And you'd go pi times 5 times 5. Because it's an area, your answer will have a label of square something, square inches, square centimeters, something like that. Whereas the other one, the circumference was just a length, so that would be plain inches or centimeters, not square ones. So those are the formulas. If you go into the syllabus and look at GED info and look at formula sheet, then you can see that they're going to tell you those. The area of a formula is pi times, and they write it as r squared, that's the same as r times r. And the circumference is either pi times diameter or pi times 2 r's. Because 2 r's is all the way across, 1 r to go there, and then another r to come out the other side. Okay, so I'm going to delete these. I have done this with someone else before. I don't want to show you the answer. So here's our formula. Circumference is pi times diameter, or pi times 2 times r, and area is pi times r. And I'm gonna actually change, no, I can't change this one. I'm gonna make this one last, if I like that. I do it first, it gets people confused sometimes. Okay. So for this first circle, we're going across is 2 inches. How would we find the circumference? If you have a calculator or your laptop or tablet does, you could do this yourself. We're going to have the circumference be pi times, so what's the diameter in this case?
2 inches.
2 inches. That's the one you want. The area. What's the radius in this case?
1 inch.
1 inch. It's half of the 2. Everyone okay with that?
Yes.
So pi times 1 times 1. I'm gonna move things. You get over here. You go over there. Okay. So for the first one, what is pi times 2?
6.28.
Yeah, 6.28. As a general rule, I will round to however many digits they gave me in the problem, or maybe add 1. So I think I will round this one to 6.3, not say 6.28. So about 6.28, and it's a circumference, so it's plain inches. And the other one, pi times 1 times 1, we saw that earlier. That's about 3.14, so I'll just round that to 3.1. And now I have to be careful, it's not inches. What should I say? Square inches. For this one, circumference is pi times, what's the diameter of this bigger circle? I'm sorry, smaller circle.
1.
1, right? Half, and then another half makes 1. So pi times 1, we just saw that, that's about 3.1 inches. And the area is going to be pi times 1/2 times 1/2. Oh, what's that going to be? Again, I don't have to worry, the calculator does all the work. Pi times 1/2, 0.5 times another 0.5, so about 0.8. Area would be square. Shits. Yeah, okay, now I'm actually gonna delete this one because I think it's more confusing than help. Yeah, okay, on the GED, they're probably not going to just ask you to do one of these plain, because that's kind of boring. And it's a timed test, so they're not gonna waste your time with something boring. Instead, they will give you something like this shape that looks vaguely like a basketball half court or something. Then what's the area of that? So I have two pieces. I have half of a circle, that's 2.9 inches. Everyone see why it's 2.9? And then I have a rectangle. So I'm gonna copy them both because I kind of want both things. For perimeter, I just need to add up the edges. I have an edge that is yellow. I have an edge that's green. What color should I make this top edge?
Blue.
Blue, I don't want to make needless colors. Which one does it match?
Oh,
Yellow, so this one is another 4.7. Okay, and now I need another color, so I need half of the circle. And that's the one that I don't know, that's the tricky part of the perimeter. So how would I find the purple one? So the purple half circle is half of the circumference. I don't want to go all the way around the circle. That would be too big, and that would be there also. I just want halfway around the circle. So first we'll find the circumference. Circumference is pi times diameter, and what was that diameter? 2.9.
2.9.
Half of that. So, and then when I'm done, I'm gonna do half of that, yeah. Pi times 2.9, 9.1, oh, okay. Then 0.5. 9.1 divided by 2. Divided by 2. Because I want half of it. So I'm going to say previous answer divided by 2 is just about 4.6 rounding. Oops. Okay, and now I can label that. That one is 4.6 inches. So now I'm all ready to find the perimeter. I just add them up. I have the 4.6, the 4.7, the 2.9, and the other 4.7. Okay, I'm starting here. I'm going around the outside. So what does that turn into? Let's see. So 4.6 plus 4.7 plus 2.9, oops, come on, plus another 4.7, I get 16.9. And I'm gonna mark that all of that stuff was just to find that 4.6. questions about the perimeter part of this problem? No, okay. Now we're gonna do the same kind of thing with the area. How do I find the area of the rectangle?
And then I multiply 4.7 by 2.9.
Yes, length times width. So what is that? 4.7 times 2.9. 13.63. And then for this one, I have to find half of the whole area. Again, I don't want the whole area of the circle, that would be too big. But that's what the formula gives me, so I have to kind of start with that. Oh, well. So the area for the circle is pi times radius times radius. What's the radius of the circle?
The radius
Yeah,
is 2.9.
2.9 is all the way across.
Oh, the radius is 1.4.5 or something like
Yeah, I
that.
have to divide it by 2, so 1.45.
Mhm.
4.5. Okay. So what do I get? Pi times 1.45 times 1.45. So,
You forgot the one.
whoops, I forgot a point, which made it very big. There we go. So it's about 6.6. Then I want half of that. So half of 6.6 is going to be 3.3 square inches. And then finally, I have to add those two pieces again. Okay, because the original thing was both of them stuck together. So I will add them up and say 3.3 plus 13.63 is going to be 16.93 square inches. So you can see why the GED loves this. It's doing stuff that the arithmetic isn't the hard part. The calculator is doing all the multiplying and adding, writing by 2 and stuff. But conceptually, it's wondering, can you break apart this shape that looks sort of like an ice rink or something into 2 pieces? Can you remember to only go halfway around the circle? Or can you remember to take only half of the area of the circle? Can you keep track of when you're doing area formulas and when you're doing perimeter distance around formulas? So it's testing how well you learned it very well and letting you use the calculator in ways that don't. Yeah, the hard part isn't the calculator part, it's the understanding the bits fitting together. Now, that's about as hard as they get, this kind of puzzle thing. We'll do a lot more of those in Math C. I would be surprised, you said you did the homework early. Did they have any puzzle pieces like this in the My Open Math where you had to break things apart? No, okay. So this is a taste of what will happen next term when you're in Math C. Maybe for this term, they just do this kind of simple ones like we did up above. Okay. The last topic we have is angles. So by the way, this one has pieces we can move around, the other two don't have or need that.
Those
Can-
fingers look like a beach ball.
They do look like beach ball. So, can you use words to explain how all of these are half shaded?
What was the question again?
Each circle is half shaded. So for the first circle, yellow is half of it. Could you use some words to prove to me that's true?
Yeah.
You can't use words, but you could
This-
use the
this one?
math.
Uh-huh.
This one goes here and that one goes there.
Okay, so I'm gonna
There
put,
We have.
I'm a math guy, I like numbers. So this one kind of matches that one.
Yeah,
This one matches that one.
yeah,
This one matches that one.
that one.
That one matches that one.
And
And
this-
that one matches that one. So there's a piece labeled 1, 2, 3, 4, 5 that's yellow, and there's identical pieces labeled 1, 2, 3, 4, 5 that's white, so it's half shade.
Hmm.
How about the pink? The pink is getting a little trickier. You can give me instructions to draw something if that helps.
Um. Can you bring me to where you're at on the thing?
Sure.
Well, that is
Mhm.
also right there. Then you could also put these two right there. Okay, well, these are the same. And these are the same.
Yeah, okay, so I'm going to imagine I pick up this piece and stick it there. And
Mhm,
imagine I pick up that piece and stick it there. And
mhm.
then there'd be this line here where this part is all purple and the other part has no purple anymore.
Oh,
Is that what you were trying to say?
no, that's not what I was saying. I was saying that if these two right here
Mm-hmm.
are the same angles, the same right here,
Mm-hmm.
but these two right here, of course, also this one is the same angle, but these two right here are like just two right here is what I mean.
Yeah, okay, so I'm gonna use slightly different words. If I fill in all these lines, then we have, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have cut the circle into twelfths. How many twelfths are shaded? 1, 2, 3, 4, 5, 6. So 6 out of 12 are shaded. How many are not shaded? 1, 2, 3, 4, 5, 6. 6 of the 12 are not shaded, so you could argue that way also.
This what? They did not word a question in this problem at all, really. Yikes.
The last one has pieces you could move around and you kind of have to do that. I'm gonna leave that as a thing to try at home. A good one to use to torture your family members or roommates. This is the hardest of the three. Can you prove that the blue is also half of the thing? Okay, on to angles. To find the distance around a circle, we unwound it. Like we pretended there was a string going around a circle, and we wondered how many widths it took to unwind the string. But what if we only moved part of the way around the circle? We want to measure just how far we turn. So somebody grab this archer, and you can take this spin me part down here and aim the archer at the blue marker instead of the.
Trying to figure it out, thanks.
You have to click on it first, and then you get the little grab me and turn me thing.
Okay, can you do it for me? I just want to do anything with it.
Just click it once, yeah.
Oh.
That's making me dizzy, honey.
Okay, so if we were just being sloppy and we didn't have to be precise, we could talk about clock hours. This is probably what you would normally do if you're just like talking about this with someone. You'd say, we're going more than 3 o'clock, less than 4 o'clock. That's about how we're aiming.
Cool.
But since we're in a math class, we want to be able to be more precise than just use the clock hours. So let's talk about how to do that.
Cool.
So there's 3 kinds of ways to talk about this: degrees, radians, and gradians. I'm pretty sure, but not 100% sure, that the GED only has degrees. So I'm going to only tell you about radians and gradians, just so you're well-educated people and can be smart. The ancient Babylonians invented degrees, and they said, well, we need to count how far the archer spins. And we want it so that spinning all the way around is some big number. And they wanted a big number that has lots of factors. Because if we said this was 8 somethings, then that would be 4, and then there's another 4 to make 8. So we could do halfway. But if our number was 8, then if I wanted to go a third, like the peace sign, I couldn't do 8 divided by 3 very nicely. They didn't have decimals. So 8's not a nice number for this. So they actually picked 360. Why 360? It had lots of factors. So if I want to go halfway around, half of 360 is 80 degrees. If I want to go a quarter of the way, a quarter of 360, what is 360 divided by 4? 90. And you probably already know that 90 degrees is what we call a right angle. If I wanted to go a third of the way around, 360 divided by 3 would be 120, and so on. So by making it this gigantic, enormous number, it's a little inconvenient because it's a big number, but you can aim the archer very precisely. You may have seen a protractor, something that measures degrees nicely for you. So your job is to take these purple labels and put them in the right place, so they're touching the circle where it goes. So I will start 360 degrees is the same as going all the way around and ending up right where you started. So Sean says 180 is halfway. Okay. Make this a little bigger so we can see on the screen here. So put it more accurately than that. If we go 3/4 of the way around, where is it aiming? Yeah, kind of right there. Where do 90 and 45 and 60 go? You can see it on the protractor. 90 is right over here. It's kind of hiding under the purple words.
So I put it back, put it there. Up here. Right here, right from my fingers at. Oh, yeah. Pattern.
Let me move this one for a moment. Whoops, no, I'm grabbing yours. Sorry. Okay, now you can see the 90s. See the 90 right there, so.
Right here, here. Pull this way, pull this way. Pull, keep going, keep on, keep on. Keep on, keep on, keep on, almost there. This one.
Oh, okay, there we go.
We'll deal with it.
I can move it a little more, just to make it legible. So there's the 90. The 45 is, let's see, 40, 50, so it's right there.
And I'll do the 60.
Oh, okay, and I'll put the 270 back where it goes. But I'm gonna take the 270 and use this rotating thing on it, so that it's not in the way anymore.
There you go.
Okay, everyone okay with that labeling?
Yes,
Everyone okay with what the protractor does?
yes.
So the GED might say, mark on the circle where the archer would turn 130 degrees. And then you would say, it would be about there. That kind of thing. Okay, so I'm gonna put in the chat, so you don't have to do this.
Protractor.
A protractor. And we can go and play with it.
I think we lost Gavin.
He's listening, he said. So how this works is you can move the blue circles and make whatever angle you want. So 90 degrees is a right angle. Yeah, and so on, all the way up to 360 being all the way around. Maybe you want to start at the top. Maybe you want to start flat, doesn't. Looks like to be like the archer, I have to do it that way. Start aiming up and then work my way around. You can click on protractor. And it should make a protractor appear on it. But I'm not seeing. There it goes, there's the protractor. Their protractor always starts with 0 down here though. And you can use a random die to just get a random angle. You can also do what's called a complementary, which is where you have 2 angles and they're sharing a 90-degree angle. You can have what's called supplementary, where you have 2 angles and they're sharing a straight line, a 180-degree. And those are the only other ones you would care about.
Cool.
So I can't see you playing with it because unless you share your screen, but now you know where that tool is and can't have fun. So try drawing different angles. Complementary again is sharing a 90-degree and supplementary is sharing a 180-degree. So those are angles. Why do we care? What kinds of things do people do with angles? You could say, if I have an already drawn angle, how big is it? Measure it with a protractor. Or you could go the other way. They could give you a number. Here's 60 degrees, draw an angle that's big. How big is that?
You could use a chop saw for angles.
You find
if
the
you-
missing number if they said in these complementary angles, this one is 30. Let's say it's 40, because it doesn't, it really looks like 45. How much is the other? Well, they have to add up to 90, so that one would have to be 50, so they add up to 90. Or you could say with supplementary, if this one was 40, how much is the rest? It has to add up to 180. So 180 minus 40 has to be 40. So that would be this kind of task. And then you could have complicated things like you see on the screen, where they give you a bunch of stuff, and then some of the angles you don't know, and you have to find them. Let's do this blue one. So somebody tells you that the angles inside any 5-sided polygon, and our polygon is 5-sided, 1, 2, 3, 4, 5. Total 540. So we're gonna trust them on that. How many degrees is this one? Well, this symbol, if you don't know it, means 90 degrees. Corner of a square or right angle. So this is that angle. I should draw it this way. So that angle is 90 degrees. How about the red angle? We know that a straight line is 180. So if this is 70 of it,
110.
then this has to be 110. Everyone okay with that?
Yes.
So then the whole thing was 540. We're gonna take away the 110 that Betty just found. We're gonna take away the 90, that was the right angle. We take away a 120 and a 100. And how much is left over for our last angle? 120. That doesn't look right. Let me see what I did wrong. 110, 90, 120.
You take away 420.
Is it doing something wrong with order of operations? Is it just really not to scale? Yeah, I guess it's just that the red one looks funky. Okay, so this is, it looks much bigger than 110, so this looks much smaller than 120. So they're trying to trick us by drawing the shape badly, but oh well, that's what it is. I don't like that one anymore. Okay. So lastly, we mentioned 2 other ways to measure circles. We could say, imagine I have a circle. I'm gonna use in the camera the top of my drink. And imagine that this circle had a radius of 1 inch, and of the friendliest circle you could imagine. So if that was true, then I could say, if I go all the way around my circle with a tape measure, it would be about 3.14 inches, right? Because pi times, I'm sorry, the radius is 1, so the diameter, it would be twice pi, so about 6.28 inches around. If the radius was 1, which this isn't, but we can pretend, then wrapping around would be twice pi, so about 6 point something. So that would be really useful if I was doing something like measuring pipes. If I'm a kind of contractor and I have this pipe, I'm trying to figure out how much something is churned in the pipe. I don't want to have to shove things inside it to take an angle like a protractor. I just want to wrap a tape measure around the outside. So this style of measuring angles by just looking at the distance outside is called radians.
Right.
And again, if the circle had a radius of 1, then if you go all the way around, that would be 2 pi radians. So it would be 2 for the diameter times pi. So that's kind of weird. That would mean that all the way around is 2 pi. So halfway around would just be pi radians. A quarter of the way around would be pi divided by 2. Because it's this much was pi, or half of that. A 45-degree angle would be pi divided by 4. And you can see more like that. I don't really care about this. I don't think you have radians on the GED, but your calculator has a radian button. So now you know what it does. It's a different way of measuring how far. That's great if you're the kind of contractor that doesn't want to stick your hand inside the middle of circles. You're just measuring on the outside. The penalty you pay is that all of your answers have pi's in them, instead of nice things like 90 as an answer. I would much rather look at 90 pi divided by 2. But if it means I don't have to stick my hands in pipes, it might be worth it. The last thing is called a gradient. Gradients you might never hear about in your whole life. They're a kind of failed attempt to make angles metric. Never caught on, they just don't work well. So unless you're part of a French artillery division trying to aim your cannons, you will never hear the word gradients, you can forget about it. But again, your calculators might have a button on it that's called grad, and so that's about gradients, ignore that part of the button.
Mm-hmm.
Okay, now you know more than most people about angles. So we're done with all the new stuff. All we have left is the giant readiness check. It's 7 o'clock, so we should take a little stretch break. And then we can come back and I will compare or talk a little bit about our readiness check here and how it compares with the readiness check down here and things like that. But for now, I'm going to pause our recording and we can take a little break. So I wanted to do something as a break before we jump into the readiness test. Because there was some big news that happened within the past week about large language model AI. So depending on if you're an old dinosaur like me, you might remember how big a deal it was in the Macintosh when people invented the mouse. Suddenly you didn't have to type on a keyboard to tell your computer what to do. There was this whole other way to tell your computer what to do that a lot of people thought was easier for most things you want to do. So something like that happened last week. One company, ChatGPT, released a new version called Omni, and you can take it on your phone. And if you have paid money, which I haven't, then you can talk to it and it will talk back. And you can show it things with your phone camera and it will see them. So you could show it yourself and say, you know, what color shoes go with this outfit. Or you could show it a flower and ask it to identify it or things like that.
Is it like talking to Siri?
Except it's a large language model, so Siri is getting that way, but Siri is still not quite doing all the things a large language model does. But the fact that if you are willing to pay money, you can now just talk to your computer or show it stuff is sort of as big a deal as when the mouse was invented. Here's a whole new way to get things communicated to your computer. So there's one called Pi, just Pi.ai, named after the Greek letter pi, so that sort of fits with today. You can go to just pi.ai, so I will put that in chat if you want to play around with it. Or you can put it on your phone, and if you put it on your phone, then you can talk to it. And I was making it take the Myers-Briggs personality test just as for kicks. But I think that. I think if I talk to it, since I'm signed in on both things, then whatever I say here, it will show up on the screen, which will help just because we're recording lectures. So I'm gonna show you a few things of how the AI have gotten better in the past, basically 3 months. First, I'm going to ask it to do the math problem that we already did. So this math problem here, I'm going to ask it to solve it. It just reads text out loud, so it tends to be very bad at pronouncing math formulas. So I'm curious how well it will say 0.8 square inches and things like that. It might be funny. If I look at it in the text, it should be more accurate. So don't trust its text to speech yet. It's still working on that.
It knows you and say, good evening, David.
Yep, well, I signed in, so. Then the second thing is now you can ask the AI, even these free ones, why things work. So after we ask it to do this problem, I'm gonna ask it to explain why that works. And that didn't used to work very well a few months ago, but now it does. So that might help you if you are taking the summer off and you come back and you're rusty at some things, then you could always go to my YouTube channel and find all the old things we did this term, but it might be quicker just to ask your phone, hey, why is it true that the circumference of a circle is pi times its diameter? I'm curious what it will say. And it probably will be smarter and have a better answer by the time the summer is done, the way the AIs are developed. And then, yeah, I think just those two. And if you want to play around with it, we can. It's not like we're in a rush. But I wanted to show you both that it can do a math problem and that it can explain why. You can't trust the accuracy of them very well because the way the large language models work, they are predicting what should go next. They're not actually doing that. So if people have done this problem on the internet before, then when they are using the internet to help predict what to do next, they will have a good idea because this problem has happened correctly. But if we ask a problem that no one has done on the internet, it might just make up something as an answer. So they are not as reliable as a calculator, which is why I'm still showing you how to plug things into formulas and not just saying, hey, we don't need our calculators anymore. Okay, but for now I'm gonna ask it, hi, what's the circumference of a circle whose radius is 1/2 inch? And let's see what it says. What is the circumference of a circle whose radius is 1/2 inch?
To calculate the circumference of a circle, we use the formula C2PR, where C is the circumference, P is the mathematical constant pi, approximately 3.4159, and R is the radius. Given that the radius of the circle is 1/2 inch, we have R 0.5 inches. Now we can plug this value into the formula. C2, 3.44159, 0.5, C, 3.44159 inches. So the circumference of the circle with a radius of 1/2 inch is approximately 3.4159 inches.
So you hear it mispronouncing some of the numbers. It said 3.44, not 3.14. And it didn't say times when it was reading out the formula. It said C 2, 3.44, and so on. So it doesn't do well with formulas. But if you look at the text, see the steps for this.
Cool.
Okay, now let's see if it can explain like we did back here. So why is it that the distance is that? And really historically, the answer is because they named it pi, right? The ancient Greeks knew that this was more than 3 and it wasn't a precisely anything. So just whatever it is, they named it pi. Let's see what we can see. Thank you. Now, why is the circumference of a circle pi times diameter.
The fact that the circumference of a circle is p times its diameter is a fundamental property of circles and is a direct consequence of the definition of p. Let's break it down step by step. 1, the diameter of a circle is twice the radius d12r, since it's the distance across the circle through the center, whereas the radius is the distance from the center to any
Okay,
point.
I'm gonna stop it. So it's saying p instead of pi, which is kind of funny because it's named pi and it's not pronouncing that Greek letter it's named after. Anyway, so it started with the correct thing. It's just a fundamental property. That's just how circles work. They named it pi. But then they're giving you an example they didn't ask for, which AI does a lot. It likes talking. Okay, in any case, if there was something we've done, then it's always kind of interesting to see if the AI is smart enough these days to explain not only an example problem, but why it works. Because more and more it can do both. Anyone have a question that they want to ask? See what it knows. No, okay. I think by the time my kids have kids, right, my grandkids might not have to touch buttons on a calculator. They'll just talk to the thing and say, now what's 3 times 4? And it will say 12 and be accurate.
How long will it take to have AI do everything for us?
That was a good one, Gavin.
Now we're getting into my conjectures. And I'll just say a few things. One, that probably the biggest difference AI will make isn't about actually the AI. It's that the technology has been around to make small, safe nuclear reactors. And
Ooh,
hospitals have been wanting these for about a decade. Because if the power goes out, it's really nice if your hospital has power. So a nuclear
You
reactor.
don't want to go to
that's-
the hospital with no power.
Right, so a nuclear reactor that's safe and as big as a house and could provide all the electricity for a college or a big hospital or things like that. The reason they haven't been made is government regulations. But
Yeah.
the companies that are making AI takes a tremendous amount of energy and water. Each time you ask the AI to draw a picture for you, it's about a cup of water to cool the computing system. So they're built by lots of water. Anyway, so the companies that are making these AIs, which are big companies, with a lot of influence, are now pushing the federal government to say, release your restrictions on these small nuclear reactors, let us start building them so we can not get rid of San Francisco's power running the computing system near San Francisco to run AI and so on. So the fact that energy might get much more cheap is probably a bigger deal for us and our kids than the
Where's
fact
San
that
Francisco?
we can talk to our
Where's San
phones.
Francisco again?
And we've got Northern California, a lot of the tech is Bay Area.
Isn't that like the?
So, Bella.
Yeah, I don't think we should build a nuclear reactor in San Francisco. That'd be bad.
It's
Especially if
okay, Gavin, we're not going to San Francisco, it's okay.
There will probably be lots of small ones, and you can read about these.
okay.
On that, so that's one thing, it's just the availability of energy, the cheapness of energy will probably change a lot in the next decade.
Yeah, technology back in the 80s, they used to have old nuclear reactors. Now we're getting more smarter, more like not the toxic waste they use from the nuclear waste. They're trying to make more cheaper, easier.
And the small reactors, the waste you can actually use to make certain kinds of medicine.
Yeah.
So it actually is useful instead of just something to bury forever.
Yes.
Wait, how do you make it?
Go ahead.
Out of the waste, like what kind of medicines would they make?
The type of radioactive material you need to run X-rays things. So medical equipment, not medicine, like you take it in your mouth.
Yeah, that's,
Okay. I thought you said like
In your mouth.
medicine,
You don't
not
want
medical,
radioactive items.
right?
no,
Then the other thing is that currently, like my phone and Chloe's phone don't talk to each other. And she is sick and can't make it to class, she's polite and she emails me, so on. What the AIs will probably involve again in the next 10 years, if not sooner, is all of our phones will learn more about us. Because if it has a friendly voice, we can talk to it, people will just start talking to it. And then they will remember things about us. My phone will not only have my Google Calendar know that I teach Tuesday, Thursday nights. But probably the AI will know that I teach Tuesday, Thursday nights, either from the calendar or because I've mentioned something to it. You know, hey, phone, where's traffic in
I feel like that's spying on us, like too far.
So once I have given a lot of my personal information to my phone and it knows what restaurants I search for and when I work and things like that. Then if it's an AI, it can talk to other AI, it can talk to Chloe's phone on her AI. And maybe my phone will someday just say, by the way, Chloe is sick and can't come to work without her having to send an email politely.
yeah.
So that's two things.
Does your phone tell you when your anniversary is?
Oh, cause I put it on the calendar.
You're trying remembering it.
Provides you.
Other things, people say, will AI take my job? And the answer is probably not, but there's probably someone that does the same kind of job you do. And they're a little more efficient because they've learned how to use AI to make it easier. So be the person that does your job with help from AI. Not lose your job to someone that does what you do, but has benefits you don't, so. And then lastly, remember that they are trained on what happens all the time in the internet, that's where they get their training data. So if there's the parts of your job that's just the same day after day after day, if I am a doctor and I'm wondering how to plug numbers into a health formula, or how to read a growth chart for a kid, or things like
And
that.
AI does that
Then
for
the
you.
AI will learn to do that. What the AI isn't going to learn to do is when things go crazy at work, whatever your job is. These putting out fires, emergencies that don't happen every day, because if it hasn't happened again and again and again on the internet, the AI won't know how to deal with that. So your value as an employee will increasingly be, do you know what to do when things are going bad? Not, can you do the boring repetitive things? The boring repetitive things will be more and more what the AI does for us.
However, HR could be like, hey, we should, set it to do that for us and keep a track record and ideas, and in doing that, they would have different backup plans each time.
Somewhat, yeah.
You could I don't know, make it prioritize that.
But again, it can't learn something unless it's seen examples of it again and again and again and again. That's just how these large language models work.
But
Oh,
then I guess you could say even the unions and different shops could probably do a group effort, or even just people who are business partners, say the shop that does all the woodworking. They could that they'll have people from other places that provide the wood. They're gonna want to have data on that too. So
you can pull together data to have a big data set. Yeah, but there'll still be the things that just don't go well. So if everyone turns out to be teaching like I do, which isn't gonna happen, then what do you do the day that the internet is down at downtown center and I can't get Moodle and Zoom working? what should I do? You know, that kind of thing, I would have to improvise now, but I would still have to improvise, because that doesn't happen enough to give an AI any training.
Oh,
Okay.
I was thinking about like simple problems that always occur.
Okay, let's learn about math C now.
Yeah, let's go to the Math C readiness check. We're not gonna finish this today, but that's fine. We have, again, all of the rest of this week and next week to do this. We're probably gonna finish this one
So if we
in
don't finish this today, we can
way
do it
more,
on
because it's
Thursday.
big, but it's not that big. I can make another version that has just different numbers but looks the same. If you go into our Moodle shell, then there's the Math C readiness check at the bottom. It doesn't have anything in books and boards, just a link to the same whiteboard where we always are. It doesn't give you any new videos, because this is all review, so go back to the other topics if you need to look at a video. And there's no new worksheets. But when you go to My Open Math, then there is a version of the readiness check in My Open Math. So I copied the same style of problems from My Open Math when I made this one. That's not quite true. There's a pencil and paper version that came first. So I got from the Math B lead teacher their paper and pencil version, and I built this off it. And whoever programmed the My Open Math one supposedly did the same thing. So it might not be that problem one looks like problem one and problem two looks like problem two, but there should be a lot of overlap when you are doing the My Open Math one than what we do today. So that probably means wait till we do things together here, because it's more fun together. And then when we've done a bunch here, then you can try in Moodle and see how far you get. Okay, so I'm done talking a lot. Now it's your turn to all be here. And whoops, no, not present.
David, what did you do?
I hit present instead of bring everyone to me. Okay. Okay, let's see if
Yeah,
we
my
can do
computer
this one.
can't wait.
As much as possible, I've made these all where you can drag things and not have to write. Some of these pages I will have to be your scribe. But for now, it's asking what place value is the bold and underlined digit? Okay, so the 5 for A. Oops. Okay, so ones, tens, hundreds, yep, that is hundreds. For B, ones, tens, hundreds, thousands, 10,000s, 100,000s, okay, that got there. And then ones, tens, hundreds, thousands, so. There we go, good job. I'm gonna move on to the next slide.
Did I get it right or wrong?
Wrong. Sorry about that, but. So, okay.
Okay, now you have, for part B, for problem 2, you have 3 parts, A, B, and C. A uses the red numbers, B uses the green numbers, C uses the blue ones. So with the first one, if we're rounding to tens, then I'm going to say what I care about are the tens. What happens one place smaller? Is that 7 5 or more? Yes, 7 is 5 or more. So that makes the 4 get one bigger. So the 4 turns into a 5 and I get 150. Everyone with me for that? So now for B, I'm gonna look at this 9. That's the tens I care about. I'm gonna say, what's one smaller? This is gonna make the 9 get bigger, because it's 5 or more. So what happens when that 9 gets bigger?
A 10. That one?
Yeah. Not 790 when I get bigger by 10 is going to turn into 800. That makes sense? Okay, and then this one, the number I care about isn't the 10, but the nearest 1,000. So is the 6 gonna make the 2 get bigger or not?
No. Right?
6 is 5 or more, so that will make it bigger.
Hmm.
If it was 62,140, then it would stay 62,000. But since that 6 is 5 or more, then things go up. Okay, a similar kind of thing is which is greater? 64,654 or 64,564? That is,
This one.
so the 6 is the same, the 4 is the same, but this 6 is bigger than that 5. So this one is bigger. Okay. This one I can't really do during class. Oops, go away. Cause I have to look at your work. So one big problem with this style of class is because I can't see the paper for the Zoom people, then I have trouble evaluating if you're writing work on paper nicely. If you tried to do the first one very sloppily, it would make life harder for you. If you just said 9, 6, 8, and 8, 70, and 13, and I'm gonna add them all up, and none of my place value was lined up or anything, maybe you'll get the right answer. But that's just asking for trouble. Does that make sense? So how you write things makes a big deal. So what I would really love for this is if between now and Thursday's class, you did these 4 problems. And then took a picture and sent it to me by email. If you're not gonna be here in person. If you're gonna be here in person, just show me your paper.
Okay, cool.
And then I can check and breathe a sigh of relief and say, yes, everyone has good habits of writing things on paper.
Yeah.
So that's why it says, show me your work or a photo of your work. And we could take time to just do this in class. But I think since it's 7:36, I'll say, please, if you can, get this one thing done before Thursday's class. I'll include that in the email after class, that we're gonna work on that one. I'll send a screenshot. Then this is the same thing, but I'm giving you the answers because it's a little trickier with decimals. Your answer should be one of these. But actually, this one could be less tricky if you remember the shortcuts. Which decimal scoots does times 10 times 100 do, or divided by 100 divided by 10? So why did you do that one so quickly, Sean?
This is, cause the 0 times the first answer, the first, phrase, was 758.0 times 10, and you had to move things 0, 1. Decimal.
They move the decimal point right one, that's what
Yeah.
times 10 does.
Yeah,
Who remembers what times 100 does? Other than Sean.
and that's what I'm giving them a chance.
You remember? If 10 was one scoop, what's 100?
Here. Pointing them, look. Pointing it.
Oh. 4.230.
That is the answer, but other than the fact that he's saying your cursor happened to be on it. So review your scoots, times 100 is 2 scoots, and that's what. Divided by 100, if times 100 is 2 scoots to the right. She's remembering divided by 100 is 2 scoots to the left. So that's what happened there. And if divided by 100 is 2 to the left, what's divided by 10?
4.9.
And 1 to the left.
Yep, 4.9.
Or-
Go ahead, Betty, go and get it.
Okay. Yay. So when somebody says do arithmetic by hand, they don't always mean write something big. You could just write these scoot arrows. People know that you know what's happening.
Yeah.
Okay, here's another thinking one. Somebody drinks 12 8-ounce cups of coffee and 13 12-ounce cups of coffee. Hopefully they're doing this at home and not having to pay for it at a.
Wow, it's a lot of coffee.
That's a lot of
That is
coffee.
a lot of coffee.
So, whoops, we didn't actually ask the question, did we? How many ounces did he drink? Oh, okay. So if we have 12 8s and 13 12s, what's the total? So again, show me how you write that on your paper. And then part B, there's 128 ounces in a gallon. If you had to pick, is he closest to 1 gallon, so 128? Or is he closest to 2 gallons? So 128 times 2, 256. Or is he closest to 3 gallons? 128 times 3, 380.
256 gallons he drank.
Huh? Are you certain?
Show me on paper how you did it. So, okay, let's get back to one we can do again. So this is another by paper one.
Where was that again? I missed the board.
Okay, here's a coloring one. We did okay on the warm-up today. Pick any of these shapes and show me coloring 1/2 and show me coloring 3/8. And maybe somebody is picking one shape and you're gonna show off and do it a different way on a different shape. I'm gonna pull people towards me again.
Only one.
Honey, I was going for that one.
Sorry about that.
On you,
Okay.
fine. I'll go over here then.
Okay, so he picked the one that was clearly 2 halves and shaded half of it. Jody is fancier. She picked one that had quarters and is shading 2 of the quarters, because 2 quarters is also 1/2. How about 3/8? Who wants to show me a 3/8?
Here.
No, yeah, again, we're not grading you on your artwork, so 3 out of the 8 are shaded. Is there another 3/8 we can shade on this page? Yeah, one of the circles is 1/8 too. You could be extra fancy. What if instead of shading lumps that are all touched? Remember to warm up about which of those circles were half faded? You could have said, I want to shade this one and that one and that one, and that's 3/8 also.
Okay, cool.
But the simple way is probably better on a test.
You got me there.
Okay, which fraction of the square is shaded blue? You can use the text box to type your answers.
Oh, in text, but should.
And now which one am I going?
3/8.
Betty is saying the bottom one is 3/8, the top one is 1/9, so I know that.
Mine's kind of small.
4/9, yep, that's right too. Everyone okay with that?
Yeah.
Okay. Looks like we have time for one more. This one we haven't done much, it's really a Math C topic. I'm curious how well you can work together as a team. So some of these fractions are the same as 2/5. I had.
I can't do it.
Okay, so I have 2/5. If I broke each piece into smaller pieces, then I could have other things. So if I cut each one in 2, now I would have 1, 2, 3, 4 out of 5, 6, 7, 8, 9, 10. So 4/10 is the same, but there's no 4/10 on the board because because you moved it already. Okay.
I got it.
Or if we broke each piece into 3. So if we had 5 and now each is 3. What's 5 times 3? 15. And we had 2 of them shaded, but now each of those has 3. So there's a times 3 on the top also. So then we have 6 that are shaded, right? 1, 2, 3, 4, 5. So if you multiply by the same number top and bottom, that's what we're doing. So some of these work and some of them don't. But this is Math C stuff. I'm putting it on the test because it was on the thing I'm copying from when I was given the master test. But it's a little like extra bonus work.
Look at an idea.
Okay, we have time for one more. Oops.
Well, about 3 minutes left.
And let's save this for next one. Can you read a graph? What was the top selling item, things like that? Let's just start here. So actually, we're gonna start with the, did you write things nicely? Where did it go? That one. So I'll see if I can leave it the whiteboard here and maybe we'll remember that for Thursday.
Cool, I'll move it over there.
So, yeah, if you could bring everybody.
I know.
So I think you got it. Alright.
Okay, I'm gonna stop the recording.